Okay, hi everybody. Sorry about canceling class today, but I wanted to make sure that you guys got the information from class this morning, what I had planned to do. So there's a handout on D2L that's about correlation and regression, and it's in chapter 4 and in chapter 5. Chapter 4 is about correlation, and chapter 5 is about linear regression, where we actually try to fit a model to some data. So first thing I want to look at is in this section, we're going to start talking about bivariate data, where we've got two numeric variables that are going to be not necessarily compared, but we're going to be looking at a relationship between the two variables. So the first thing I want to look at is this first data set that is height and weight data. Okay, and it looks like I've got quite a lag on my camera right now. So I'm going to put those numbers into my calculator, and I want to show you just a couple things. First thing is kind of the wrong thing to do with this, that if I was interested in looking at the graphs of these, one thing that I could do is I could go into second y equals, and I could set up a couple of plots. And the first one, let's say that we're interested in making a box and whisker plot of their heights. Okay, and then I could go into plot number 2, turn it on, and make a box plot of the weight. Okay, so list 1 is the heights, and list 2 is the weights. Right, and then if I wanted to make a graph of this, I could just hit zoom and then number 9. Right, it's going to create a couple of box plots for me. All right, now the problem with this is that I can see that, all right, well, the heights are over here, they're a lot smaller than the weights, and it looks like they're less variable. All right, but what I can't really tell is how is this guy's height related to his weight? Okay, he's 6'4" and 200 pounds. I want to be able to see the relationship between those. So this is probably not the best way to do that because I can't really tell which of these points on this box plot correspond to which points on this box plot. Okay, so I'm going to make a little bit of an adjustment here and go back to second y equals, and I'm going to turn the plots off. I'm just hitting number 4 to shut them off. And then I'm going to go back to second y equals and just turn this first plot back on. Okay, the graph that I really want is I'd like to think about these as a bunch of ordered pairs or points in the plane. And that's what this first graph is it's called a scatter plot. All right, so I'm going to select that one, and it's going to ask me, what is the x list? All right, and it seems like it would make sense for me to call this x and we'll call this y. All right, so the x list is list 1 and the y list is list 2. Okay, and then I can pick down here what kind of a symbol I want to use as my points in the plane, and since I've only got 10 points, this little square works out pretty nice. All right, so once I get that set up, then I can just hit zoom and then number 9, and I get something that looks like that. All right, a scatter plot. All right, now what I'd like to look at is, if you look at the next page of your handouts, it really just kind of walks you through how to set that up and how to make the graph. But when we look at the graph, what we're going to be interested in looking at is the relationship between height and weight data. Okay, so the height is along the horizontal axis and the weight is along the vertical axis. And what you should be seeing here is that there's generally a trend where we've got several points that are down here in the bottom left and several points up here in the top right. Okay, and there's a general like lower left to upper right trend in the data. All right, and so when we see something like that, we'd like to talk about the direction. And so the direction of this one, I would say, looks to me like it is a positive association. Okay, and then I also want to look at the strength of the relationship. And the strength of the relationship is that if you kind of imagine that there's a straight line that goes through this data set, it's how closely are those points clustered around a line or some other kind of a curve. And so I would say that the strength of this relationship is fairly strong. Okay, so I'm going to say moderately strong. Okay, and then do we see any deviations from the overall pattern, right? And by deviations from the overall pattern, what I'm thinking of is there any points that really don't follow the general trend? And I would say that in this data set, I don't see anything that really is out of the ordinary. Okay, and then also in deviations from the overall pattern, does it seem like a linear model is appropriate here? Okay, do these look like they line up along a straight line? All right, so I would say that this is a fairly strong, positive, linear association between height and weight. Okay, now the next thing I want to look at is how do we measure the strength and the direction of the relationship? Okay, and we have a way to do that, just like we had a way of measuring center and we had a way of measuring spread with univariate data. Now we've got this statistic. It's called the correlation coefficient. And the correlation coefficient measures the strength and the direction of a linear relationship. Okay, and what this formula says to do is to take each one of these ordered pairs, look at each x value, and this should look familiar. This is just a z-score for the x value, and then this ends up being a z-score for the y value. Okay, and then our formula says to take those z-scores and multiply them together. This thing says add them all up, and then after we add them all up, we're going to divide by a number that's fairly close to n, okay, just n minus 1. Okay, so in order for me to do this, okay, I need to know what's the mean, what's the standard deviation of both the height and the weight data. All right, and let's see, we can do that fairly easily just by doing one variable stats on list 1 and list 2. So if I do stat calc one variable stats on list 1, I see that the mean height is 69.5. And the standard deviation here is about 3.44. And then for the weight data, the average weight is 184.5, and the standard deviation here is 19.5. Okay, so to get the value that goes in here, okay, for this first person's z-score for his weight, okay, remember a z-score is take an x value minus the mean divided by the standard deviation. So we're going to take 69.5, no, I'm sorry, we're going to take his height, 76 inches. We're going to subtract the mean of 69.5. And then we're going to divide that by the standard deviation 3.44. Okay, and we end up with about 1.89. Okay, so 1.89. Now remember what that tells me about this guy. It's he's about 1.9 standard deviations above the mean for his height. Okay, then we're going to do the same thing for his weight. He weighs 200 pounds. So 200 minus 184.5. And then divide that by the standard deviation of 19.5. Okay, so we get a z-score for his weight that is about 0.79. Okay, so that tells me that this guy, he's 200 pounds. He's about 8/10 of a standard deviation above the mean for his weight. All right, so this guy he's really a lot taller than he is heavy. All right, and then the formula says to take those two values and multiply them together. All right, so if I do that, take this one value and multiply by the other value, we get about 1.5. Okay? All right, and then we want to do that for every single one of these ordered pairs. Okay, and then I've done that on the next page for you. And these are the values that we ended up coming up with. So notice that some of these values are positive, some of these values are negative. The ones that are positive are the ones that are above average for either height and or weight, and the ones that are negative are the ones that are below average for height and weight. Okay, and then you'll notice that we multiply these together. Sometimes we get a positive product and sometimes we get a negative product. Okay, so what I want to look at then is the formula says to take all these products and add them up. That's what this says to do right here. And then divide by, in this case, that's 9. Okay, and when we do that, we get a value of about 0.84. Okay, and that number is the correlation coefficient. All right, now there's a few things that you should know about the correlation coefficient. And it is on kind of a continuum that I think that some of you probably already know that the correlation coefficient is got to be a number that's between -1 and +1. Has to be somewhere in between those two. Okay? And when we get over, and let's say that we also look at 0 in the middle. All right, so when we get out here to, let's say, about 0.7 or so, and anything greater, these R values would be a fairly strong and positive association. Okay, anything that's over here from -0.7 to -1 is also fairly strong, but negative. Okay, in other words, the graph is going to go down from top left to bottom right. Okay, and then anything that is basically from about -0.5 to +0.5 is weak. Okay, anything in there is a weak correlation. All right, looks like just a scattering of points. All right, so our value of the correlation coefficient was about 0.84. It sits right out here someplace, and therefore we're going to say that this is a fairly strong positive linear association. All right, there are no books that really say where these cutoffs are, but this is just kind of a visual that anything from about -0.5 to +0.5 is pretty weak. Anything that is in absolute value bigger than about 0.7 is fairly strong. And then these that are in between, like about 0.6 or so, you know, they are kind of on the bubble of what you want to call them, strong or weak. Okay, and then I also want to look at how this formula kind of works. If I call this a z-score for the x value, and I call this a z-score for the y value, and we look at this graph, notice that this graph is, these are not the coordinate plane. These are not the coordinate axis, I should say. These are the average x and average y. Right? And so if we were to calculate a z-score for an x value, for the guys that are up here in this top right-hand quadrant, that z-score is going to end up being positive because these points fall to the right of this average height. Okay, and if I go over here and say, what about the z-scores for x over here? These are going to be negative because they fall to the left of the average height. Okay, down here, same thing. Z-scores are going to be negative, and over here, z-scores for x are going to be positive. All right, and then if I look at the z-scores for y, z-scores for y is how they rate in terms of their height. Well, these guys that are above the horizontal axis are above average for their height, for their weight. And so these two values are going to end up being positive. And then down here, the z-score for y is going to be negative, and the z-score for y down here is going to be negative as well. All right, now if you think about what does the formula say to do, it says take those z-scores and multiply them together. So if you take two positive numbers and multiply them together, we're going to get a positive product here in the first quadrant. And if we take z-scores over here, one of them is negative, the other one is positive, we're going to get a negative product of z-scores over here. Down here, if they're both negative, we're going to get a positive product. And over here, we're going to end up getting a negative product. And so if you look at where all of our points are, all of our points lie in this first quadrant or this third quadrant, except for this one point here. Okay, and that point is this one. It's 69,200. It has a negative z-score for the height, but a positive z-score for the weight. And then you end up getting a negative product. Okay, but because there's only one negative number in there, we end up still with this thing being relatively large and positive, 0.84. All right, so what I'm hoping that you see is that if the points generally were in this quadrant and this quadrant, the second quadrant and the fourth quadrant, then we would end up getting a lot of negative products, and we would get a scatter plot that kind of comes down like this from top left to bottom right would give us a negative correlation coefficient. Right? And then if you imagine that, let's say you've got points that are scattered in all four of the quadrants, and if you've got them scattered in all four of the quadrants, you're going to end up with a bunch of positive numbers and a bunch of negative numbers over here, and you're going to end up with a correlation coefficient that's close to 0. Okay, so a lot of this is visual, like how strong is the relationship, and we have to make a judgment on how strong we think something is. Okay, but I think that this is a fairly reasonable scale for you to be thinking about when you see a correlation coefficient and how strong the relationship is. Okay, so that is the correlation coefficient. Now there are quite a few homework problems that I want you to be aware of, that this is not the way that I really want you to calculate a correlation coefficient. Okay, setting up a table, something like this. Okay, this is a lot of work, and there's a better way that we're going to be doing this, and we're going to see that on Wednesday. But on Wednesday, we're going to be talking about linear regression and fitting a line to the data, and we're going to find out how our calculator will do that for us. Okay, so I want to show you some stuff with the homework while I've got you here. There is a little bit of attention given to which one of these is the explanatory variable and which one is the response variable. Okay, and so it seems like if we're talking about height and weight, and we want to think about which variable might explain the other one, it seems like we could go either way on this. If we knew how tall somebody was, we might be able to say something about how much they weigh. If we know how much somebody weighs, we might be able to say something about how tall they are. Okay, this next data set is the number of people that went out to dinner and how much their bill was. It seems to me like the number of people in the party would be the explanatory variable, and how much their bill was would be the response. Okay, this one down here with ACT scores and hours of sleep the night before the exam, it seems like number of hours of sleep might explain the score, so we call this one the explanatory variable and this one the response. Right. Now, it doesn't mean that one of them causes the other one. It's just that one of them would tend to explain the other one. Okay. If we were looking at, let's say, one data set was the heights of a man, and the other list was the height of his wife. Okay, and we wanted to know which one is the explanatory variable and which one is the response. Okay, it really wouldn't make sense for me to say either one of those is the explanatory and the other one's the response, because the relationship could really go either way. All right, so I've got a couple of questions that are going to ask you that in the homework. So let's take a look at how those are worded. So here is the question bank. And if we just take a look at this first question, it says, you have data in a large group of college students. Here are 4 pairs of variables measured on these students. For each pair, is it more reasonable to simply explore the relationship between the 2 variables, or to view one variable as the explanatory variable and the other one as the response? All right, when I first read this, I was expecting to see like 4 ordered pairs here, but then if you read the question over here, this is part A. The number of times a student accesses the course website for your statistics course and the grade on the final exam. Okay, which one of these is the explanatory variable? It seems like the number of times they look at the website would be the explanatory variable, and the grade on the final would be the response. Okay, so it looks like this one. So let's check that. Okay, and we're right. Okay, so you've got several questions that are like that, but then I also want to show you how to come up with the correlation coefficient and some of those things. So here we've got how does the fuel consumption of a car change as its speed increases, and the table contains data from the 2013 Volkswagen Jetta. Okay, speed is measured in miles per hour, and fuel consumption is measured in miles per gallon. All right, so it says to make a scatter plot, and then which is the explanatory variable? It seems like the speed would be the explanatory variable. Right, and then when we go to make this graph, let's go down here to pull that into crunch it. And we're going to go up here to the graphics, and I want to go down here to scatterplot. And it's going to ask me what is the x variable and what is the y variable. So we click on this chevron, we'll get speed is the explanatory variable, and fuel consumption is the response. Okay, and then the rest of this stuff we don't have to do anything with at this point. All right, so when we say calculate, that's going to give me a scatter plot. So we can see that there's one point down here and it kind of goes up and then down. Okay, all right, so that's to make a graph. Now, if you want to find the correlation coefficient here, we go over to statistics and we go down to correlation. Okay, and I want the correlation between speed and fuel economy, and then calculate. All right, and it tells me that that correlation coefficient is about negative 0.64. All right, so it's a relatively weak negative association. And if you look at just these points that follow this kind of linear pattern, those would have a much stronger negative association. But because of this point here, that kind of makes this a much weaker association. Okay? All right, so if we answer that question, and then we'll go on to the next stuff. So speed, and we'll check the answer, and looks like we're okay. So if we go on to the next question then, now it's asking about describe the form of the relationship. All right, so if we go back to the graph, and we notice on the graph, whoops, that's not it. It's, let me get it again. So we go to the graph, make a scatter plot, speed and fuel economy, and then calculate. All right, so they're looking at this goes up and then it goes down. And because of that, they're saying that this isn't a very strong linear pattern. All right, and so if I go back here to this question, it says the relationship is curved downwards overall, but with a pair of outliers. This makes sense because neither a perfect fit nor a straight line should be expected for such a complex machine. All right, I would say that that's probably not the case. I think if we go down to these other ones, we say the relationship is curved. Okay, low at the two extremes, high towards the left, and steadily decreasing as speeds increase. This makes sense because most speed limits in the city are around the speed where the peak occurs in the graph. Okay, and I think that that's a pretty good answer. Okay, and this one says it's curved, it's low at the two extremes, high towards the left, and steadily decreases as the speed increases. This makes sense because engines are designed for specific speed, temperature, and RPM ranges. Driving out of these ranges goes against the fundamental design of the engine, leading to less efficient fuel. Okay, I don't think that that one is correct, but let's check this answer. Oh, it doesn't like that one. Let's try that again. Maybe it is the last one. Okay, there we go. All right, so it was the last one. I guess that does kind of make sense, that the faster you go, you're going to end up with less fuel efficiency and so on. Okay, so I wanted to show you how Crunch It works and just some of the questions that are going to be asked here. I do also want to show you, let's see, we found the correlation coefficient. So when we go into Crunch It, you're going to be using the graphics and you're going to be using the statistics. Okay? Those two things are going to be the two that you're going to be using. And under graphics, we're going to be using scatterplot, And under statistics, we're using correlation. Okay, when we get back on Wednesday, we're going to be looking at how do we fit a line to the data, and we're going to be using this option to use the regression to fit a line to the data. Okay, I'm hoping that I'm feeling better on Wednesday. I am planning to get a COVID test. I don't think it's COVID because I think I've just had a touch of the flu. But anyway, I hope this helps you guys on your assignments for today, and I will see you all on Wednesday. Okay, thanks. Bye.